Hello everyone. Today I am going to start with chapter 1 of class 10th mathematics. Name of the chapter is real numbers. Now real numbers are of two types, rational numbers and irrational numbers. Now what is a rational number? A rational number is a number which is terminating or non-terminating but repeating. Terminating means when a number ends after some decimal places, then it is known as terminating. And non-terminating repeating means when a number repeats a certain pattern after decimal places, then it is non-terminating but repeating. For example, 9.52. It is a terminating number. It ends after two decimal places, hence it is a terminating number. Now 9.525252 and when it's keep going, it is a non-terminating but repeating. That means it never ends, कभी खत्म नहीं होता, but it repeats. But repeat करता है, like 52 is repeating so many times. Now what is an irrational number? Non-terminating but repeating means when a number doesn't terminate and also doesn't repeat after decimal place, then it is a irrational number. For example, 9.5237896754 and it's keep on going, then it is a non-terminating and non-repeating. ना कभी खत्म होता है ना कभी repeat करता है, कोई भी pattern repeat नहीं करता. So this is the difference between rational and irrational numbers. You have already studied this in standard 9th. Now let's go to the new topic, which is Euclid's division lemma. Euclid's division lemma. What is lemma? Lemma is a statement which is a proved statement and used to prove another statements. That is, एक स्टेटमेंट जो पहले से ही प्रूव की जा चुकी है एंड वो यूज होती है बाकी अदर स्टेटमेंट्स को प्रूव करने के लिए, देन इट इज कॉल्ड अ लेमा. देयर इज एन अनदर टर्म नोन एज एल्गोरिथम. सॉरी, algorithm. What is an algorithm? It is a step-by-step process. Algorithm we use to solve questions. It is a process and it has steps. So algorithm is a step-by-step process and lemma is a proved statement. This is the difference between the two. Now what is Euclid's division lemma? So Euclid division lemma state that if we have two numbers, if we have two positive integers, if we have two positive integers, A and B, let's say A and B, then there exist unique integers Q and R satisfying A equals to B into Q plus R. That is, if we have two positive integers, अगर हमारे पास दो पॉजिटिव इंटीजर्स हैं a and b, तो उन दो इंटीजर्स के लिए हमारे पास दो ऐसे नंबर हमेशा होंगे, यूनिक नंबर्स होंगे q and r, जो कि हमारी इस इक्वेशन को सेटिस्फाई करेंगे. So this is our Euclid division lemma. Now this is used to solve or used to find out HCF of two numbers. HCF is highest common factor. So there is an Euclid division algorithm which we use to find out HCF of two numbers. Now Euclid's division algorithm. Let's take an example. We have two numbers 18 and 22. Now, how we use Euclid division lemma or Euclid division algorithm to find out HCF of these two numbers? The question is find HCF. So how we find out HCF of two numbers? Let's see. First, we will see which is greater. So 22 is greater than 18. Now we will divide 22 by 18. So when we divide it, this will 1 and 18, remainder is 4. Now this is our dividend, this is divisor. So this dividend becomes the divisor. If we write this in the form of Euclid division lemma, that is 22 is equals to 18 into 1 plus 4. Now the dividend becomes the divisor and the remainder becomes the dividend. That is, now we will divide 18 by 4. So when we divide 18 by 4, this will be 4 and 16. Now 18 can be written as 4 into 4 plus 2. Now here, this is the remainder and this is the dividend. So these two numbers, this 4 will become the divisor and 2 will be the dividend. And this process keeps on going until we reach where remainder is 0. जब तक remainder 0 नहीं आता तब तक हम ऐसे divide करते रहेंगे और dividend को divisor and remainder को dividend बना के the process will continue. So now here we have 2 as the dividend and 4 as the divisor. So this will be 2 to the 4 and the remainder is 0. Now here the remainder is 0. Remainder is 0. That means 2. 2 is the HCF of 18 and 22, as 4 can be written as 2 into 2 plus 0. Remainder is 0. Hence 4 is the HCF. So HCF of 18 and 22 is 4. This is Euclid division algorithm. Now let's go to exercise 1.1. of your NCERT. So what is the question 1 of NCERT? It is find out HCF of the following numbers using Euclid division algorithm. So we will do question 1. Question 1 is use Euclid's division algorithm to find HCF of the following. So I am doing the third part of this, that is 867 and 255. Now 867 is greater than 255, so 255 is our dividend and 867 is our divisor. So we will divide 867 by 255. So this is the remainder. We are left with the remainder and the question. So now the remainder is not equals to 0. Remainder is not equals to 0. So we will continue the process. Now we will divide 255 by 102. So 51 is the remainder. Again remainder is not equals to 0. So 55 will become our dividend and 102 will become our divisor. Now we will divide 102 by 51. So this will, here remainder is 0. It means 51 is the HCF of 867 and 255. That is HCF of 867 and 255 is 51. So this is the HCF. Now let's take another question of your exercise 1.1. Let me take question 5. Question 5 is use Euclid division lemma to show that cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. That means कि किसी भी पॉजिटिव इंटीजर का क्यूब हम इन तीनों फॉर्म्स में लिख सकते हैं. ये हमें प्रूव करना है, यूज करना है यूक्लिड डिवीजन लेमा. व्हाट वाज यूक्लिड डिवीजन लेमा? What was Euclid division lemma? It was if we have two positive integers a and b, then there exists two numbers q and r such that a equals to b q plus r. So we have to use it and prove it that cube of any positive integer can be written in 9m, 9m plus 1 or 9m plus 8. So let's start. the solution of this. Let's take a positive integer a be a positive integer and let's take b equals to 3. So when b is equals to 3, according to Euclid division lemma, a is equals to bq plus r, where r is always less than 3 and greater than 0. It can be equals to 0 because it is a remainder, so it will always less than 3 the divisor and always greater than 0. Remainder is always greater than 0 and less than 3. So what will a become? A can be 3, b value of b is 3, so a can be 3q plus, what are the values of r here? 0, 1 and 2. These are the possible values. So if r is 0, then a becomes 3q plus 0, that is 3q. This is our case 1. And if r is 1, then a becomes 3q plus 1, case 2. And if a is equals to 3q plus 2, then this is case 3. So we have these 3 cases, 1, 2 and 3. Okay, so we will solve these 3 cases and prove the required thing. So let me clear it. So let's start with case 1. A is equals to 3q. And what is a cube? 3q whole cube. So a cube is 27q cube. It can be written as 9 into 3q cube. If we take 3q cube equals to m, then this can be written as 9m, where m is 3q. Okay, so a cube is 9m. So we have to prove that any positive integer cube can be written in the form of 9m, 9m plus 1 and 9m plus 8. So first thing we have proved a cube can be written as 9m. Now let's take the case 2. So case 2, when a is equals to 3q plus 1, cubing both the sides, a cube is equals to 3q cube plus 3q का whole square plus into 1. We are using identity of a plus b का whole cube. So this is 3 into 3q into 1 का whole square plus 1 cube. We have used here the identity of a plus b का whole cube, which is a cube plus 3a square b plus 3ab square plus b cube. So here I have used this identity. So now a cube here will become, a cube will be 27 q cube plus, this is 9 and 3, 27 q square plus 9q plus 1. Now we can take 9, as we have to prove 9m plus 1. So we can take 9 common from these three terms. So 9. Here we will left with 3q cube plus 3q square plus q plus 1. Now a cube was 9 3q cube plus 3q square plus 3q plus 1. So if we take this whole as m, then this will become 9m plus 1, where m is 3q cube plus 3q square plus 3q. So this is a cube. So second case we have also proved 9m plus 1. Now the last case, that is case 3, where a is equals to 3q plus 2. Cubing both the side, a cube equals to 3q plus 2 का whole cube. Now here also we will use the identity a plus b का whole cube. Using a plus b का whole cube, that is a cube plus 3a square b plus 3ab square plus b cube. This will become a cube will equals to 27q cube plus 3 into 3q square into 2 plus 3 into 3q plus 2 का whole square plus 2q. So a cube is 27q cube plus 54q square plus 36q plus 8. So if we take 9 common from these three terms, it will become now if we write this as m, then a cube is equals to 9m plus 8, where m is equals to 3q cube plus 6q square plus 4q. So if a is any positive integer, then its cube can be written as 9m plus 1 and 9m plus 8. So we have proved that if a is any positive integer, its cube can be of the form 9m plus 1, 9m plus 8. So this is all for today. You guys can practice your exercise 1.1. If there is any doubt, you can comment in the comment section. So if you like the video, please like it, share it, and subscribe to my channel for more upcoming videos, and press the bell icon. And comment any suggestion. If you have any suggestions, all suggestions are welcome. If you have any doubt, then comment it. Thank you so much.